Now see here toroid. Toroid is actually considered an endless solenoid. So see here in this case there is a hollow circular ring on which large number of turns are made which are closely wound and the current is passed through this is here. When current passed through this is here, it produces magnetic field. So now we are going to use Ampere circuital law to calculate magnetic field at the point P, at the point S and at the point Q. So see here the point P is inside the toroid, that is in the empty space of the toroid. Point S is inside the core of the toroid and where is the point Q is outside the toroid. Now for using Ampere circuital law, we have taken here the 3 loops. One is loop R1 of radius R1 which is drawn here, and another loop this is S which is of radius R2, and third one is the loop here the outside which is of the radius R3. So from this side here the outer surface of this ring, current is coming out of the plane of the paper and here the current is going into the plane. So the current is outward perpendicular to the plane and inward perpendicular to the plane. So outward perpendicular to the plane has been shown by the dots and the crossed here by the inward or into the plane. So just see, let us assume the first loop. If you are taking the loop 1 and we can apply Ampere circuital law here. So in loop 1 we can write B dot dl is equal to mu naught I, that I am talking about the loop 1 only here. But see here in the loop 1 I is equal to 0. So we can write here B dot dl is equal to 0. It means there is no magnetic field in this loop. Now take here loop 3. So we can write in loop 3, this is the outward at the point Q. So we can again write here B dot dl is equal to mu naught I. But see here in loop 3 again the net current is 0, because whatever the amount of current is coming outward to the plane and same current is going into the plane. So the total net current will become 0. So again here we will be writing here B dot dl is equal to mu naught into I and we will be getting B equal to 0. This is 0 here. So the magnetic field at point Q is also 0. So now we can take the loop 2 now and we will calculate magnetic field. So see here in loop 2 we can write here this is B dot dl is equal to mu naught I, because there is net current, because this loop is only enclosing the current going into the plane. Now we can write here B into 2 pi R2 is equal to mu naught I and the total current is here N into 2 pi R2. Here we can take it here in this one, we can write equal to mu naught I into N into 2 pi R2. This is here 2 pi R2 we have taken, which is here, this is the total number of turns. It means this is the total current if it is multiplied by I. So now see, we can 2 pi R2 we can cancel here and we will be getting mu naught N I. And this is also the magnetic field inside the core of the toroid, where we can write N is equal to total number of turns upon 2 pi R2 here in this case. So this is the small n is the number of turns per unit length.